Hello, welcome to my channel. So today, have a look at the question 2017 grid game. It's also the weekly contest 260. I mean the Q2 question 2 of that contest. So the question saying either given a zero indexed 2D array of size 2 times n, then uh, two robots are playing the games. So both robots start at 0, 0, and it will need to reach 1 n minus 1. So, and also the robot can only move to the right or down. So the first robot will move from 0, 0 to 1 n minus 1 and also collecting all the points. But then it will need to set all the cells it passes to 0. So the second robot again will move from 0, 0 to 1 n minus 1 and they need to collect all the points on its path. And also their paths may intersect with one another. So then the first robot wants to minimize the number of points collected by the second robot. But second robot wants to maximize the number of points it collects. And if both robots play optimally, return the number of points collected by the second robot. So let's actually look at this example, example 3. So because this grid has only 2 rows, it makes it a little easier. So in this example 3, so the robot 1 need to starting from this cell and then it end at this cell. So it will actually need to, there is one place it need to go from first row to the second row. So this place is either here or here or here or here. There is only 4 possibilities here. So actually there is only n possibility for the n columns. And so we assume this robot, first robot go at column I, and then it will, after it go from column I, then to the second row, then it will just go straight to the end in the second row. So it will mark those cells as 0. And then the second robot will start moving, and the second robot still it's going from the 0, 0 to 1 n minus 1. So, but the second robot has a second robot will follow similar pattern, but we can see actually second robot the best of second robot, actually we don't know, but the second robot can either go collect all the points on the second row, or it can collect all the points on the first row. But it actually cannot collect both, because if it goes to the second row, it cannot go back. So it actually cannot. If, for example, if it go to second row here, on the then it just can only go to the end. But if it go to the first row, go to the end, it cannot go back to collect the second row's first half of the profit, first part. So actually, it can only, that's how we say it's can only go collect those 2 type of points. So actually we can quantify those points. So the points actually are this part is the first row is a sum I plus 1, then until n. I mean grade 0. Grade, oh, we can say grade 0 j, then j belong to I plus 1 until n. So, and similarly, first row is I mean second row, or we can call it the first row if it's 0 indexed. So the first row will actually getting the sum from 0j, j belong to actually 1j. 1j, j belong to 0 to I minus 1. So it can only getting one of those two profits. So actually, it's for transit at I, it will only have it will get the max of this two. So if we call it this one A and this one B, then we will actually get the max of AI, BI. Yeah, then what we need to do is to minimize this AI and BI max for all the i's, which I from 0 to n minus 1. So actually now we can see this this sum and this sum actually is this one is we can call it a post sum, which can be pre-computed, and also this one is a pre-sum, and also it can be pre-computed. So we can actually pre-computing this two, and then we can iterate I from 0 to n minus 1, and then getting the output. So actually the time and the space complexity is both O(n), and the constraint here is n is 5 times 10 to the power 4, so it should be no problem. And also one thing we need to notice is because the n is this 5 times 10 to the power 4, and then the grid value might be 10 to the power 5. So if multiple this together, it will be exceeding the integer. That's why we need to use the long for both the post sum and pre-sum, and also for you can see the output will be also be long. So yeah, okay. So this is the thought process. So now we can start coding. So firstly, we get the column number. Then we define pre-sum. Now we can calculate the pre-sum. The pre-sum is for the column for the first row, 0 indexed first row. So maybe I minus 1. Then post sum same. So for the post sum, we need to go from the back toward the front for the and also be careful, this one need to be row 0 in the grid. So okay, then yeah, then the last step is to iterate the transition point. The transition point is also from I0 to n minus 1. So then we need to do we also need to actually I just mentioned that those need to be long because otherwise it will be out of range, like overflow. So okay, so also we need to have answer because it will be a minimum value, so we need to initialize with a large value. Then then we actually can use what we have in the equation. So pre-sum here is a pre-sum I. Pre-sum I is the one before I. Then the post-sum is a little different. We need to have a I plus 1 here for this type of then return answer. So let's try if it works. And no student. Oh, yeah, actually, no, sorry. This one not add them together, but only one of them. So okay, so it's correct, seems. Okay. Yeah. So this is concluded our this exercise. So you can see that we have pre-processed the pre-sum and post-sum, and this one we're using two loops, and then the last loop is iterating where the first robot will go down. Then we can get the answer. So so if you like this video, please subscribe or click like button, and you can comment if you have a question. So thank you for watching. See you next time.